So this morning we have a M2 in with the N55 engine for a stage 1 package. So essentially this is going to be software only, but we have a few little hardware which are these ones here. So we've got a forged charge pipe. This is mainly for reliability reasons because they're known for cracking the standard one around here. So it's an uprated part and a high flow panel filter. So the panel filter is going to just fit in place the standard one here, and the charge pipe is replaced down here. So these are known for cracking around this area here. So we're going to take that off and replace it, and it's mainly for reliability issues. So once we've done the hardware, it'll be straight on the dyno for a base run. Once the base run's done, we'll put the stage 1 calibration on, dyno test it, base log it, ensuring knock, boost, AFR, and obviously all our parameters are good. If they are, then we just obviously do it for final checks, take the customer for a road test, make sure he's happy, and we'll see what the results are. So this is the final result of the M2 N55 engine. So these are 370 PS or 365 horsepower, so it made literally standard power there. We run into a few little issues with this one. We loaded our standard stage 1 with all the calibrations in it. You notice there's a big flat spot coming to the higher revs. It made more power, 381, but still about 10-15 off where we would expect. But this dip wasn't correct, so when we was data logging it, got a lot of information on this, so there's a lot of timing being pulled out in this area of the rev range, which we'll run into in a second. So then after speaking to the customer, it turned out he's running BP 97, which is a very low quality fuel in terms of a performance engine. We had to then detune the car, taking out ignition time in the low to mid range, and instantly remove this flat spot, although it's still again about 10 horsepower off peak where we want to see. And this is all down to the customer's fuel choice, unfortunately. So we've had to put that time in the map, which removes the flat spot. However, this is now sort of mapped to suit the customer's fuel. If the customer run the high octane fuel, we could put this map back on with the high ignition. Without putting the time in, it would be up near the 400 horsepower mark on there. So we'll show you the logs on the data list now to sort of explain how that worked. Right, so blue is your engine speed, so bottom of the rev range to the top. Green is your intake temperatures. As you know on these, they get quite hot, so this one started from 30 degrees, went to 60 degrees by the end of the run. It's well covered that these intercoolers aren't the best. This is ignition timing, so this was when we first load our 99 ROM map, we'll call it. So time pulls up and instantly you got the dips in the rev range, and this correlates to the dips in the graph we were showing earlier. So this timing was flatter, the power would increase. The reason it's pulling timing is it's detecting knock or detonation, so the ECU is pulling out timing to protect itself. The more timing you can put in the engine, obviously depending on other factors, obviously maximum brake point, the more timing you put in, the more power you make, and obviously fuel quality has a big effect on this. So if you're running 102 octane, we could put even more timing and make even more power, but for most people in the UK, 99 is what we'd recommend and use, and this would create optimum power. Unfortunately, it then turned out this customer running BP 97, which is not a great fuel, not much better than 95 from what we found tuning wise, and you can see in the map with the timing being pulled out, giving us that flat spot. So then we took some timing out of the map to sort of to optimise more for the fuel the customer was using. So we'll just reference that one. You can see the timing obviously been lowered, but it's no longer dropping as much. We have still been pulling out a little bit through the rev range. Obviously this is why we're now getting a smoother power curve, whereas before it was jumping up, jumping down. So if the customer hopefully is going to come back, we're going to put it back on the dyno, we're going to run it with some 99 ROM, either Tesco V-Power or Shell, and then we'll reload version 1 of the map, and then we'll have a true comparison. But in the meantime, it shows you why running decent fuel is important. Right, we found a comparison graph actually is quite good to show. So this car is an M2 running stage 1 with running 99 ROM fuel. You actually look at the ignition timing, how much smoother it is, how it slowly ramps up through the rev range. There's a slight bit of ignition timing pulled out here, but overall compared to that one, which was up and down, and this is basically running the same base ignition timing that first one we showed you, but because of the poor quality fuel, the ECU is having to pull out the timing. You'll notice the intake temps hit very high on this one, so probably why the timing's been pulled out a little bit through here. But we've got a graph to sort of show how much smoother it is on here. So this was that same one we pulled up, and you'll see how towards the top of the rev range, which really makes a difference with the ignition time and fueling. So he's making another 10 horsepower throughout the whole rev range, even more to the limiter, and that is down to fueling alone. So always run 99.